Okay, we're having some slight problems with the webinar camera, but we'll have Tom present the microreactor presentation here from this laptop. So Tom, take it away.
Should be good to go. Great. All right. Good afternoon again. My name is Tom Sawinski, and I'm a program manager in Department of Energy's Office of Nuclear Energy. Today I'll be presenting on the Nuclear Energy University Program's RC2 scope area, which is microreactor technology development and support for deployment. Federal point of contact is myself, Tom Sawinski, and the technical point of contact for this area is Dr. Jess Jean out of the Idaho National Laboratory. To begin, I'd just like to give a brief overview of some of the benefits and applications of microreactor technologies. The DOE believes that microreactors have the potential to provide both commercial and defense sectors with clean, reliable, and resilient energy supplies. Potential benefits of these technologies include enhanced inherent safety characteristics, semi-autonomous and remote control operations, which can reduce staff needs, high temperature operation for both electricity and process heat production, and a highly integrated and transportable system, which can reduce on-site construction times. Based on these benefits, following potential applications include competitive electricity and process heat supplies for remote and off-grid communities and industrial locations, resilient and reliable energy supplies for remote and forward military bases, reliable and clean electricity supplies for disaster and emergency relief operations. Realizing these different benefits and applications, the Department of Energy's microreactor program has set the following mission and objectives. The mission is relatively straightforward. It is to enable microreactor technology demonstration at a DOE National Laboratory site and subsequent deployment of these technologies for commercial and/or defense applications. Based on this mission, we have the following objectives. First is to identify technology research and development requirements for a broad range of microreactor concepts, to perform laboratory-led early-stage research and development, which can support cross-cutting microreactor technology development and licensing activities, and coordinating with the Nuclear Regulatory Commission, the Department of Defense, industry, and other key stakeholders to demonstrate microreactor technologies on a DOE National Laboratory site. To accomplish these objectives, the program has predominantly focused on the following major R&D areas. These R&D areas were based on input from industry, Department of Defense, and other key stakeholders who provided high-priority microreactor R&D needs. One of the first areas is accelerating microreactor high-assay, low-enriched uranium production and fuel fabrication capabilities. Many concepts in the microreactor community are looking at utilizing this HALEU source for their fuel. Next is preparing potential national laboratory microreactor demonstration sites. Also, we're looking at high fidelity dynamic analysis of various conceptual designs for microreactors. We're also focused on demonstrating innovative cross-cutting microreactor technologies, such as heat pipes, advanced moderators, and other heat exchanger technologies. We're also looking at qualifying advanced high-temperature materials and exploring advanced and additive manufacturing technique qualification. We're also looking at developing remote monitoring and semi-autonomous control systems to create easier operations and reduce staffing needs. We're also assessing potential Department of Energy, Department of Defense, and Nuclear Regulatory Commission regulatory pathways to support both near-term microreactor demonstration and also for future nth-of-a-kind commercial applications. With that background, this year's scope encompasses 3 areas to support the development of microreactors. The first, RC2.1, is focused at microreactor deployment markets. This particular area is seeking proposals to analyze potential markets and applications that can take advantage of some of the unique microreactor characteristics described earlier in this presentation. Specific application topics that may require further techno-economic analyses include studies looking at the requirements and the ability to site microreactors in both remote and populated areas, and how those applications can be leveraged to support these communities. Next is assessing microreactor needs for remote industries, including mining, high-value local data processing centers, and other applications which may be unique to microreactors. Another area is evaluation of microreactors for the use of increased resilience of the existing electrical grid, and also for resilience of microgrids. It's important to note that there have been many studies recently based on various deployment markets, and it's important for applicants to know that studies should incorporate current microreactor designs and concepts, avoid duplication of market studies already performed. It should also provide recommendations for the microreactor design requirements and potential improvements to these designs relevant to specific applications for a potential market. It should also provide a data-driven market assessment for a range of microreactor sizes relevant to the markets being explored. The next area, RC2.2, is focusing on validating microreactor modeling and simulation tools, predominantly with existing experimental data or with the creation of new experiments to provide data to validate these tools. Proposals are sought to support the validation of modeling and simulation capabilities, specifically being developed by the Nuclear Energy Advanced Modeling and Simulation Program, specifically for use in microreactor design and licensing activities. Some specific areas that will need validation include neutronics validation, considering unique microreactor materials, such as unique high-temperature moderator materials, thermal and heat transfer for gas-cooled and heat pipe-cooled microreactors, which can include in-reactor heat transfer and coupling to heat exchangers, mechanics of structural systems, such as solid core blocks being pursued by several microreactor developers, and also overall integrated system performance validation. It's important to note this specific scope is focused on validating these tools and maturing them for microreactor deployment applications. So we're not focused on developing new microreactor modeling simulation capabilities. We're explicitly looking for experimental work or the application of existing experimental data to validate these tool sets based on these specific areas. Proposals should connect the proposed experiments with a clear validation need. The final area, RC2.3, is focused on microreactor technology, development, and maturation as one of the broader scopes that we have. This scope is seeking proposals to develop deployment approaches for innovative technologies or solutions specific to microreactor applications. These technologies and solutions should build upon and enhance, but it's important to note they should not duplicate both previous and existing DOE Advanced Reactor Technology RD and D efforts. So the scope is very much looking at interested in engaging the university community at seeing what areas can be enhanced upon as the next phase for microreactors. Specific areas include potential pathways to reduce the amount of HALEU required for microreactor concepts, ways to accelerate the manufacturing and fabrication for unique microreactor components, options for flexible siting, which can reduce on-site preparation needs and support site-independent designs for microreactors. Another very important area is transportation of fueled microreactors to a site and return of the used microreactor either to another site or to its original location. Another is microreactor operational maintenance regime that have the ability to minimize staffing requirements. And also, once again, integration of microreactor components, such as innovative heat exchangers, such as heat pipes, gas and or liquid coolants, to power conversion systems or process heat systems. Once again, it's important to note that technologies or research development and deployment approaches need to be described in detail and include a description of the expected improvements over the current state of the technology, as well as a potential development schedule and cost to deploy these enhancements. The technology readiness and development timeline for the proposed technology solution should also be described in detail. With that, that is the end of the current presentation. I'll now open up to any questions you have.
Please do put your questions on the question and answer box on the GoToWebinar. We'll start with the first question. Can you please clarify the meaning of microreactor, dimension, MWEs, etc., regarding the economic comparison with cellular, wind energy, diesel, and gas turbines?
Right, so that's a very good question in terms of the overall definition. I don't think there is a set definition on what a microreactor megawatt electric output would be, and a lot of that is dependent on current markets that are being analyzed. For purposes of discussion, some being looked at range to 1 to 5 megawatts electric, and I believe there are ones looking at ranges all the way up to approximately 50 megawatts electric. It'll be highly incumbent on the applicant to ensure that they show the market need and that megawatt output. Generally, microreactors are defined by their transportability, unique features, and easy deployment pathways and smaller footprints. But it'll be incumbent on the applicant to show how such of these reactors will meet the energy needs of particular markets mentioned in this proposal.
Do you expect RC 2.2 projects to focus on experimental work?
I believe 2.2 is focused on validation. Correct. So two pathways being explored is either application of previous experimental work to validate these tool sets, or developing new experiments that will generate data to validate these tool sets. So that falls within that.
For RC 2.2, would the heat transfer research area include validation of marmots, thermal conductivity models for fuel and cladding materials?
It's a little bit outside of my scope of expertise for the purpose of this, but I can take that question, relay it to our technical point of contact to better define that for you. And I'll take a note of that as well.
So any questions during the webinar that are deferred like this, we'll get an email response back to the participant, and we'll also post the answer to the question online for the entire community.
Right.
In RC 2.2, are you interested in swelling data to validate NEEM's tools for microreactors?
Once again, that's a question that we can address via the email pathway. I don't want to conjecture or steer anybody wrong on this particular area. And I'll put that as sort of a caveat for specifics in this particular area. I can relay those questions to technically and get a timely response on those for you all.
Are human factors issues of interest to this scope?
I believe we do have a broad enough category for some of the enhancements within the RC 2.3. It's relatively broad and ways to both reduce operational needs and staffing and ways to better overall operate the reactor, and human factors may fall into that. And very similar to the other scopes, it's just incumbent to show a direct need to the microreactor community and what benefits that would employ to this community, but it may fall into that area with those justifications.
What about new small experiments to close modeling and validation gaps?
Absolutely, new experiments that can fill that validation requirement are more than welcome in the RC 2.2 area.
Regarding the economics comparison, what are we supposed to compare it to? Wind energy, diesel, gas turbines, other energy sources?
Once again, this is more of an exploration of potential markets, and depending on the market that you're looking at, it would you would have to be incumbent on the applicant to see what are the leading energy markets in that particular area, what are the different resources, and even if microreactors have an applicability in that particular area. Generally, this should be more focused on areas where it seems that there's a defined market for microreactor deployment applications. It may not be competitive in terms of a base electricity production, but there may be other applications for process heat, disaster relief, energy resilience, remote applications as well. So it'll be incumbent on the actual applicant, depending what area they're looking at, to compare to those particular areas if they feel that's necessary for their assessment and their case for a microreactor to be deployed.
For RC 2.2, what could be the conceptual designs for gas-cooled or heat pipe-cooled microreactors?
Once again, I can defer that to an email and just provide some generally open available data from leading developers with those particular concepts. There are leading developers looking at both of those particular concepts, both gas-cooled and heat pipe-cooled designs, and we can help and just overall engagement with the national laboratory experts in that would benefit this particular area as well, to have a better understanding of the state of the art and the leading designs that are being explored and common cross-cutting issues they are experiencing.
What about developing new computational models?
That is not within the scope of this particular area. As stated, we are not looking for the development of new models. We're looking for the validation of current sets with experimental data.
And we have some questions about eligibility. Please refer to the presentation that was given this morning for any questions regarding process. We can follow up with those once the presentations are loaded onto the nup.gov website next week. So for RC 2.3, any new idea as part of the scope?
With the caveat that the idea needs to show a clear need by the microreactor community and also must have a detailed deployment plan and budgeting strategy, and also an exploration of the technical readiness of the item. We are looking for a relatively near-term deployment of microreactors, and we are looking for items that can enhance the current state of the art, or if it is an innovative item, what would be the pathway to bring it to a high technical readiness and its applicability to a commercial sector.
We'll keep Tom here for about another 30 seconds, so please do submit questions if you have before we let him go. Okay, thank you, Tom.
Thank you.
We will be picking the webinar back up at 2:30 p.m. Eastern time to discuss the first integrated research project that we'll be discussing during the webinar on molten salt reactor technologies. So please tune in about 10 minutes. Thank you.